We are going to attempt MCQs for gas laws. First, we are going to attempt with the medium question. Consider two identical sealed containers containing N2 at 273. One container contains 1 mole of N2 and other contains 4 moles of N2. So first of all, we need to understand one thing, that kinetic energy is directly proportional to the temperature of the gas molecule, first thing, and pressure is directly proportional to the number of moles, because PV is equal to nRT and pressure seems to be directly proportional to the number of moles. So if we are seeing pressure is greater in vessel 1, this is wrong, because pressure is greater, it has greater pressure because of 4 moles. And then force at which the molecules collide with the walls is greater in vessel 1. Absolutely wrong, because pressure is greater in vessel 2. So the collision frequency or the force will be greater in container 2. So this option is also wrong. The pressure is same in each vessel. Absolutely wrong. Second one is having the greater pressure because of greater number of moles. And the average kinetic energy of molecule is the same in both vessel because they have same temperature. So if they have same temperature, then kinetic energy is going to be same, because kinetic energy is directly proportional to temperature. So option D is correct. So in this question, what happens if we are increasing the temperature, then the new graph will be corresponds to somewhat like this, and you can see this x will shift towards right hand side, and this is going to be the new Boltzmann curve, and the graph shifts to the right, which shows that now there are more molecules which are having the high energy because of increase in temperature. So because of increase in temperature, the graph shift to right hand side, and shows that now we have more molecules with greater energy, because we know one thing, that temperature is directly proportional to kinetic energy. So fewer molecule possess the most probable energy value, so x will shift to the right. So option E is going to be the right one. So in this question, they are saying the relationship between PV against N. PV is equal to nRT. That means PV is directly proportional to N. So for directly proportional graph, we have a graph somewhere like this. There is going to be the straight line. So A is incorrect, B is incorrect, C is incorrect. So D is going to be the right one. So for this question, an experiment is conducted to calculate the molar mass of an unknown gas of known mass. Measurement of pressure, volume and temperature are taken during the experiment. Which condition of temperature and pressure would give the most accurate value of molar mass? So first of all, for ideal gas behavior, there are certain conditions which we need to keep it in our mind. That is, there is no internal structure, and then it must also need to have no volume and random motion, and then it is going to be no intermolecular force, and then it is going to be no loss of momentum in collision, no loss of momentum in collision. So if we need to follow this condition, for that purpose the temperature should be high. Temperature needs to be high because at high temperature no force of attraction is going to develop, and pressure needs to be low because at low pressure particles are away from each other and the chances of developing intermolecular force of attraction would be minimum. So our answer is going to be A. So for the next question, they are saying 0.96 of hydrogen gas is contained in a sealed vessel of volume 7 liter and a temperature of 303 Kelvin. So first let's find out the moles. Moles is equal to mass divided by molar mass, that is 2.016, and the answer comes out to be 0.476. And then if we want to find out pressure, then that is going to be nRT divided by V. N is the number of moles, which is 0.476, and R is going to be the value, that is 0.08206, that is atm per mole liter atm per mole per Kelvin. Why we are using this unit? Because every other thing is in this unit, so it's liter and Kelvin as well. So now what we can do, we can put this value of R 0.08206 times it with temperature, that is 303, and divided by volume, which would be in liter. So our answer that comes out to be is 1.69 atm. So that is going to be B. Similarly, for the next question, first we are going to find the number of moles. So mole for chlorine is equal to mass by molar mass, which comes out to be 70.9, because chlorine exists as Cl2. It's a diatomic gas, and that comes out to be 0.075 moles. And when we are going to find the temperature, that is equal to, we know formula is PV is equal to nRT. If temperature stays there, then PV over nR, and pressure is how much, that is going to be 1 atm, and volume is how much, that is 1.25 liter. Number of moles is 0.075 mole, and then we have R, the value of R, which is going to be 0.08206 liter atm per mole per Kelvin. So temperature finally comes out to be 203 Kelvin. And the right answer is going to be D. In this question, they are saying there are fraction of particles on y-axis and molecular speed on x-axis. So you can see one thing, that they both are at same temperature. So why this relationship is developing? Because if we were following that y is going to have greater temperature, then in that condition graph goes on the right hand side. But why, if they have same temperature, then why the molecular speed of y is greater? Now the reason could be molecular mass. So particles with greater molecular mass have low speed. So which is going to have low speed, as x is going to have low speed, so we can say that it is going to have greater molar mass. That is why it is having low speed. because temperature are same, and that one is having low molar mass, and that is why it is having greater speed. So our answer is going to be A. So for this question, which graph shows how the average kinetic energy varies with temperature? Kinetic energy is directly proportional to temperature. So the graph that represents directly proportional is going to be having the straight line. So which is having the straight line? That is option D. So this question, a mixture of three gases in a sealed container is able to generate 4.5 atm of pressure. The identities of amounts of each gas are as follows: 0.3 moles of chlorine, 0.4 moles of N2, 0.5 moles of AR. What is the partial pressure of nitrogen gas? If we want to find out the partial pressure of nitrogen gas, the formula is going to be mole of nitrogen gas divided by total number of moles times with the total pressure. So total pressure has been given to us. What is the moles of N2? That is 0.4, and at bottom it is going to be 1.2, which is going to be the total number of moles times it with the pressure, that is 4.5, and that comes out to be how much? That is 1.5 atm. So the right option is going to be B.